In this video, we're going to be learning about pH and pOH and how they relate to the pH scale. So this is an introduction to pH. Okay, so we've learned before that there's the acid-base scale, or the pH scale, and it goes from 0 to 14, and right in the middle is neutral. We know that a pH from 0 up to 7 is considered acidic, those are our acids, and from 7 up to 14 are our bases, or our alkaline compounds. Now we know according to the Arrhenius theory that acids are things that produce H+ when they ionize. So acids are going to have a high H+ concentration. And we know that bases, when they ionize, produce an OH- according to Arrhenius. So they're going to have a high concentration, and that's what these brackets mean, concentration of OH-. So how does this relate to pH? Well, it all is based on the idea of what neutral means. Neutral is a pH of 7. Well, what does that mean? That means at neutral that your concentration of H is equal to your concentration of OH. So for neutral, we're going to say the concentration of H equals the concentration of OH. Well, that means then that your pH equals your pOH, and we'll learn more about those terms in just a moment, but that our pH would equal our pOH. Okay, so we're going to take that information and we're going to apply it to what we know about both acids and bases. We know with acids they're going to have a high concentration of H. And so since they have a high concentration of H, they're going to have a low concentration of OH. Then on the flip side, we know with bases they're going to have a high concentration of OH and a low concentration of H. And so now we're able to relate that to the pH scale because we know that it's goes up to 14. So we know that the pH plus the pOH equals 14. So that's how we get this idea of 7. The pH is 7, the pOH is 7, equal concentrations, so 7 plus 7 equals 14. So if we were to look over here at an acid, let's say we had something that had a pH of 1. If it has a pH of 1, it has a pOH of 13. And then for the bases, if we had, let's say, something with a pH of 13, it would have a pOH of 1, because 1 and 13 add up for 14, and then 13 and 1 add up to 14. So we can always take our pH plus our pOH and add it up to 14. Okay, so what does this term pH or pOH mean? Well, pH has an inverse relationship with the actual concentration. So if we were to draw a graph and we were to label concentration on the bottom and we were to label the p-value, whether we're talking about pH or pOH, the higher the concentration is, and we know that the closer we get to 0, the more and more H's we're going to have, the lower the pH number. So it's going to be an inverse relationship. The smaller the concentration, the higher the pH number, or the pOH number. The greater the concentration, the lower the pH number. So we know that's going to be an inverse or indirect relationship between concentration and pH. And we also know that when we're looking at pH and pOH, we have pH here at the bottom and pOH here at the top. We know that they also have an inverse relationship. Right at the middle is where they meet for 7. But they're going to have an inverse relationship. If the pH is 1, the pOH is going to be 13 because they're going to add up. If the pH is 13, the pOH will be 1, and so on, because the two values must add up to be 14. So that's kind of our introduction to acids and bases. Now we have to learn how to calculate them. So we're going to look at a couple of equations. We're just going to introduce those equations. All right, so here is our first equation when we know pH plus pOH equals 14. Well, how do we calculate pH? pH equals the negative log of the concentration of H+, and pOH equals the negative log of the concentration of OH-. We're going to use pHs when we're talking about acids. We'll have to plug in the H concentration. And if we're given a base, we're going to have to use this, pOH, because it's going to dissociate or break up and give us OHs. Okay, well, what if I give you the pH and you need to figure out the concentration of H? Well, we have a way to do that. The concentration of H is going to equal 1 times 10 to the negative pH, and the concentration of OH- is going to equal 1 times 10 to the negative pOH. OH. And we're going to use these three equations in order to be able to help us solve some problems. So we've got pH plus POH equals 14, pH equals the negative log of H plus, POH equals the negative log of OH minus, H plus is 10 to the negative pH, and OH minus is 10 to the negative POH. Okay, so just kind of as a recap, we know that on the acid-base scale, the more acidic it is, the closer it is to 0, that means the more hydrogens you have, the less oxygen, the less hydroxide, because we know that there's an inverse relationship to that. We also know, though, that there's an inverse relationship between concentration and the p-value. So the more concentrated it is, the lower the p-value is going to be, which makes sense because you're going to have more H's as you move towards 0, and the pH is going to decrease. That's an inverse relationship. As we go up the pH scale toward 14, the pH value increases, so that means the H value decreases. And we can see that as the P value increases, the H value is going to decrease. On the opposite side, if we're looking at POH, the closer we get to 14 on a regular pH scale, the more OH we have, that means the lower the POH value, but the higher the pH value. Inverse relationship. Okay, that is our introduction to pH. In the next video, I'll show you how to do a couple of practice problems.